I'm going to review lab 4 and the assignment 4, and then we'll go into something called if statements. So if statements control the logic of a program. So we're going to get into a lot of logical deduction, which is one of the core concepts of programming. A lot of programming is logical. So if I do this, or if this result, the logical direction of your program will change as a result. So let's do lab 4. Lab 4 was using the random number generator and the math library to complete these two problems that you see here on the screen. So the first one is to write a program that randomly generates a maximum number between 100 and 200, then generates another random number from 0 to the maximum number before, and prints that second number to the console. So for example, the first one randomly generated was 147. The second one is 81, and then we print that out to the console. So let's do that. All right, file, new, Java, lab, public class, lab 4. All right. Again, the first two lines of any program, and y'all be mindful of how I write my programs as well. How I indent it. So your class sits here, the first indentation, right? I hit enter a couple times, then I use the tab button, then I write my public static void main string args. All right. Reason being is in Java, we know that our main is inside of our class. So therefore, the way I indent it represents this main is inside this class. So be mindful of your indentions, all right? Similarly, inside my main, I want to indent again so that whatever code I type here is inside my main, all right? So for this lab, our first thing is to do a random number generator, new random. Right? We're going to need that throughout this entire program. In order to use that random number generator, we do need to import java.util.random. Right? So in order to use that random number generator, we do have to import it into our program. From there, we're going to generate a random number between 100 and 200. So we know our random number generator can only do from 0 to a maximum number. So ran.nextInt, and we do 100, it only generates a number between 0 and 100. Even if we put a 2 right here, it's going to generate a number between 0 and 200. However, for our purposes, we want it to be from 100 to 200. So in order to do that, we would randomly generate a number between 0 and 100, then add 100 to that. All right. Now, when you actually run this, what you'll find out is this generates a number between 0 and 100, excluding that actual 100. So technically, it only goes to 0 to 99. All right. So in order to do actual 1 to 100, we will need to do plus 100 and 1 right here. All right. That gets us a number between 100 and 200. All right. Actually, it gets us 101. Actually, let's keep it like this. All right. Let's keep it like this for right now. And in here, we would put 101. So now this generates inclusively 0 to 100. Then we add 100 to that. If we just put a 100 here, inclusively, it only generates from 0 to 99. All right. So I'm going to put a 101 right here, then plus 100. That gets us our first max. And basically what I wanted you to do in number to generate a random number between 0 and whatever that max is we calculated before. And then print both of those out. All right. Then print both of those out. So to be similar to this, we want to print the randomly generated maximum number and print that out. So system.out.println. Now, many of you didn't have this. You just printed out the numbers. That's fine too for right now. But as we progress in this class, you're going to have to do more printing out. The randomly generated maximum number. Then we concatenate in that max number that we generated before. Then we print out the second number, system.out.println. The random number is, and then we plus concatenate in number. And that would finish our program. Again, be mindful of your indentation.
You forgot a parentheses.
What was that?
You forgot a parentheses after the print line statement.
Oh, that's right. Appreciate that. All right. So remember your indentation. So since I'm closing my main method, I want to go back a couple, close that main. Since I'm closing my class, go back a couple, close my class. And you see, this just looks more readable. If I look at this, I say, okay, the topmost block is my class. Inside my class, I go in, I have my main. Inside my main, I go in, I have this code. So it just makes it more readable. Putting your brackets on different lines or new lines also makes it more readable as well. Some people choose to code like this. They make their brackets like this. That's fine too. I like to do it like this. Either way is fine. But be mindful of how you code and how it looks, right? So if I run this, save file, lab 4. It's saying no main found in my class. Public static void main string brace args. All right, now we should be able to run it. There we go. The randomly generated maximum number was 180. The random number is 143. If I run this again, it should be different. Yep, 131 and 65. I run this again, it should be different. Each time it should be different because technically it's random. All right. Everybody clear on lab 4?
Yeah, slightly, but yours comes out with 2 numbers. Mine only comes out with 1.
So that just means you have one print line statement. You only have one of these. Okay. So you need to have another one, print out the max and print out the number. Cool.
Can you leave it for a second so I can screenshot it, please?
Mm-hmm.
Thank you. All right, thank you.
No problem. All right. So, part 2. Now we're solving the Pythagorean theorem. So what I want you all to do is randomly generate a number for A and B from 1 to 50, then calculate C using the Java math library. All right. C, actually I should have said C squared. That's technically the area. C squared is the area, if I'm not mistaken. And I know the output down here is probably wrong as a result. All right. So I'm going to use this same file just because I don't feel like creating another one. All right, again, we need a random number generator equals new random. Then we'll say int a equals ran.nextInt 0 to 50, and then plus 1, because we want it between 1 and 50. We don't ever want to get a 0 for this example. The next one, we do the same thing. NextInt 50 plus 1. Cool. Now we have our two random numbers. I'll put some comments in here. Generate two random numbers for A and B. Put another comment. Create the random number generator object. All right, so that's what I'm doing so far. Everybody with me so far? All right. Lastly, we would say double area, or we can name it whatever we want. So I'll say C squared equals math.pow A squared plus math.pow B squared. Again, when we use power, math.power, the first number is the number that's going to be our base. The second number is our exponent. All right. First number is the base. Second number is the exponent. So I'm saying A squared. I'm saying B squared right here. The last thing is print out these three numbers. System.out.println A system.out.println B plus B system.out.println area plus C squared. So I'll add some comments here. Calculate C squared with the math.pow library. And then down here, print out the two numbers, A and B. Then right here, print out C squared. All right. And there we go. So I think some of you all, you just had area. You didn't even have this. You just printed out the numbers. That's fine for right now. As we keep progressing through class, I will be marking off if your output doesn't match at least this part of the output, right? Your numbers will be different. These numbers will be different. But these prompts right here should be similar. So random A, random B, and area. Over here, I just need to change mine to random A and random B. And now it should be similar, or identical actually. Yep, random A, 4840, and area. Run this again. It should be different each time. Is that clear? So that was lab 4. All right. Let's move on to assignment 4. Assignment 4 was very similar, except now we're reading things in from the console. And if you look at this example or the directions, if you see something in bold, that stands for user input. So this is user input. Down here is user input. All right, so then you would use that user input in your program. So the first one, it says Write a program that prompts the user to enter a maximum number, then generates a random number between 0 and that max, and prints that random number to the console. So if we go back to what we had before, I should have did this in a separate file, so let me do that. I'm going to keep this right here. This is part 2.
Mr. Brown,
Go ahead.
Caleb got kicked out again. He's telling me to tell you that let him back in.
All right, I got it. All right. So this one, public class assignment for P1. I'm just going to name it that. All right. So, and this will be very similar, public, static, void, main, string, args. Inside our main, we had our random number generator. And I'm just repeating what we had before for lab 4. And then we had int max equals ran.nextInt to 101 plus 100. Number equals ran.nextInt to max. We did system.out.println the randomly generated max plus max, and then system.out.println the random number is plus number. So again, this is what we had for the lab. All right, that's the lab. So we can start here as a base, and then we did have our import statement, import java.util.random. This is the base. So all I need you all to do was change this line, all right, and move this. So I wanted you all to read, instead of generating a random max, read that in from the console. So anytime we want to read in from the console, we do need a scanner. So we have to import that, java.util.scanner. Then we must create a scanner object in order to use it. Input equals new scanner, system.in. All right. We want to move this up here so that we can prompt the user for it. And I believe I said, please enter a maximum number. So I'm going to change this. Please enter a maximum number. And instead of int max equals ran.nextInt, all that, we'll instead say input.nextInt. That's reading it in from the console. So scanner input is our scanner object, so we say input.nextInt. That reads in that value from the console. Now if I run this, you'll see it says, it'll say down here, please enter a maximum number. I enter 55. The random number is 17. It generates a random number between 0 and 55, then prints it out. I run this again, I can enter in whatever number I want. I can enter in a 600. Generates a random number. If I do it again, I can enter in a 700. Generates a random number. So you just have to change a couple lines from the lab to the assignment. If I enter in a 900, 542. There were just a couple lines you needed to change. All right. I'll let that sit there for a second. Any questions? All right, let's move on to problem 2. So in problem 2, instead of generating random numbers for A and B, I wanted you to read those in from the console. So if we go back to our lab, we are randomly generating these numbers. Instead, I want you to read those in from the console. So this one was pretty straightforward. You only had to change 1, 2, 3, 4 lines. So up here, instead of random, we want to import our scanner. Instead of creating a random object, we want to create a scanner object. Scanner input equals new scanner system.in. Then right here, we would say scanner.next int. Same thing right here. Scanner.next int. We do want to prompt the user to enter in those numbers, so I would put prompts in here as well. So I'm going to move this in, move this up here. Please enter A. Make this a print statement instead of a print line. Move this one as well. Make this a print statement instead of a print line. Please enter B.
Professor,
Go ahead.
so when we make these codes, right, do we have to move them up like that, or can we just leave it in the same order and then just?
Well, you would have to change the order at which they come, because when you run a program, it goes line by line. So I want you to read in A and B first and then calculate the C squared. If I left these prompts down here, I mean, it would print it out at the end. But what you'd see is, and I'll actually just do it real quick. What you'll see is the program will wait without telling the user anything. So if I kept it like this and I ran it, well, one, it's not gonna, so this is actually input. This is input as well. What you'll see is the program will just wait. You see down here, it's just waiting. And actually, let me clear that and rerun this. It's just waiting. It doesn't say anything. But I know, because I wrote this, it's waiting for me to input 2 numbers. So 5 and 10, and then it keeps going. Right? Because I didn't change the order of these, it's going to wait first and then print everything out. But I wanted to tell the user what to enter in. So that's why I'm moving this up here. Please enter A. And then same thing with this line. Please enter B. And now what you'll see is it'll tell me what it's waiting for. So down here it says please enter A. So now I know I need to enter an A. Then it says please enter B. And then it keeps going. So that's why you change the order. So this was the full assignment right here, part 2 or problem 2. Any questions? Any at all? Again.
Yes, actually.
Go ahead.
So your code, the way you just typed in this code, is going to definitely look a little different from ours because you're more advanced, right?
I would assume so.
Okay. I'm not trying to match this then. Okay.
Like I said, programming is like writing a book or a paper. Most people don't write papers exactly the same. We word things differently. We use different words. Our syntax is going to be a little bit different. Programming is much the same way. Now, these early programs will be fairly similar. But like I said, what we're going to cover today is if statements. Once we get to if statements and all those different things, your programs will diverge slightly from one another, which makes catching plagiarism a lot easier. All right, so if you have any questions and you don't feel like asking them in class, or this hasn't fully digested yet, send me an email. We'll set up a time. We'll meet, discuss, yada, yada, yada. Or on Friday, which is 2 days from now, we'll also have the opportunity to talk face to face, and you can ask your questions there. Good on the lab, good on the assignment? I'll assume so. And we will keep going. All right. So if statements. So we come across if statements in life all the time. And you may not even realize it, but it occurs all the time. So for example, I think most of you drive. If not, this may not, at least you would have observed this. So when you come to a stoplight, right, you go through a couple different if statements in your mind. If the light is green, go through it. Else, if the light is red, you stop most times. Else, if the light is yellow, you speed up, right? That's just the common things that most people do. If it's green, you go through. If it's yellow, you speed up to go through. If it's red, typically you stop, but there's certain situations, if you're 5 feet away from the line, you might keep going. I don't know how you all drive. It just depends. So that's an if statement that we encounter every day that you may not even realize. It's a logical, our brains go through a logical step that we may not even consciously realize, but we can represent that in programming, right? For example, self-driving cars, they will have this logic built into the software. It'll read the light. If it's green, the car will come to a stop. If it's yellow, self-driving cars are pretty conservative, so if it's yellow, it'll probably stop as well. However, if it's if it's green, it'll go through. If it's yellow, it'll come to a stop. If it's red, it'll stop as well. Right? So self-driving cars have this logic built in. So as programmers, you can use this in your program. For example, the past example we just did, we can say if the area of that triangle is greater than 200, that's a big triangle. However, if it's less than 10, we can say it's a small triangle. So we can do this in programming. We can if else our way through a program and kind of control the logical direction of our program. And that's what we'll talk about today. I kind of just talked about this briefly. We can, account for if the radius, and this says a circle, but if that triangle, if the area of the triangle or the user inputs a negative number, we can say that's an error. You can't have a negative length, right? At least I don't think you can. It's been a while since I took geometry. I don't think you can have a negative length of a triangle, right? So we could check for that. If the number that the user enters in is negative, print out an error. So this leads me to describe what a Boolean is. A Boolean is either true or false. There are no other values a Boolean could have. So if this is true, move on. If this Boolean is true, keep going. However, if this Boolean is false, stop. So we go back to our red light, green light, yellow light example. If the light is green is true, we keep going. If the light is green is false, we go to our next one. Then we check. If the light is yellow is true, we keep going. We speed up, then keep going. However, if the light is yellow is false, We move on to our next one. Then we check if the light is red is true. Then we stop. If the light is red equals false, I don't know what the other situation would be. It's either green, yellow, or red. If there's another situation, it's one I am not aware of. So that's what a Boolean is used for. It's either true or false. If this light is green is true, we keep going. We can also create Boolean variables. So Boolean over 20, over 20 once, should be over 21. Over 21, I imagine for most of you it's false, but some of you it might be true. All right. So over 21 equals false. It could be true for some of you. But for me, Boolean over 21 is true, right? But for some of you all, it's false. So in Java, we have some comparator characters, right? We can do comparisons. If, let's say, for example, if radius is less than or equal to 0, we can check for that. If radius is greater than or equal to 200, we can check for that. If radius equals, so you have to use the double equal sign to do equals, we can check for that. Be mindful of less than and less than or equal to. Those are two different operators. So for example, if I say if radius is less than 0, that means radius could still equal 0. However, if I say less than or equal to 0, that means it's going to account for all of those situations, including 0. Right? So be mindful of that. There's also not equal to. So we can check if radius doesn't equal 55, do this stuff. Right? However, if radius equals 55, do this. There's just different operators you can use to check for different numbers. All right, so now let's get into the actual code. So the if statement is used to control the logical operation of a program. If something is true or false, execute a set of code. So for example, int birth year equals integer.parseInt system.in. That doesn't really make any sense, but basically I'm saying int birth year equals something we read in from the console. So something the user types in. I created these slides last year, so 2020 was most recent. So if birth year is greater than 2020, you cannot be 0 years old. Obviously, this would be 2021 now. So if birth year is greater than 2021, you cannot be 0 years old, right? You can't be 0 years old. So that was something I wanted to check for. However, every other birth year would work, except for anything greater than 2020. So let's do something that looks very similar to what you all did. Instead, we're going to be computing the perimeter and area of a circle, right? And I believe this was assignment 3. If the inputted radius is less than 0, print an error, right? We don't want to use a radius less than 0. So this was assignment 3, I believe. So system.out.println, please enter in the radius. We read in the radius. This line looks a little bit different than what you all have done, but basically this converts, a string into a double. Instead, you all use input.next double. Same thing. This is just a little bit more code. So we do radius equals this double that we read in from the console. Then we do perimeter equals 2 times radius times math.pi. Area equals radius times math.pi. System.out.println, perimeter, yada, yada, yada. Right? But we want to check if the user enters in something less than 0. You can't have a radius less than 0. So if radius is less than 0.0, system.out.println, radius is less than 0.0. Right? You can't do that. So the first couple lines, we're declaring our variables. Then we're prompting the user for the radius. We create our scanner object. read the next int or the next double. Then we check if radius is less than 0. If so, if that's true, we print this out, radius is less than 0, right? That's an error. However, the program continues. It does the if statement and it keeps going, right? So think about that. We don't necessarily want that to happen. If they enter in something less than 0, that should end the program right there. It should not keep going, all right? And we can check for that. We're using if-else statements. So if this is true, do this. Else, if that's false, go to our other statement. So in order to change this logic, because previously the program keeps going, it keeps calculating perimeter, calculating area, printing it out. But we want it to only do this if radius is greater than 0. So we can use an else statement. If this is true, print out radius is less than 0. Else, print this out down here, right? So what happens is the program goes down here, checks for this. If this is true, it prints this out and it ends. However, if this is false, it goes down to our else statement. So if this, else, or do this. So again, we go through this, we declare our variables, we enter in the radius, right? So let's say, for example, the user enters in a -14. Goes here, it checks if the radius is less than 0.0. And again, remember radius, for this example, they enter in a -14. It goes in here, and then our program ends. It doesn't continue doing the rest of these statements. If the user enters in a number greater than 0, so for example, if they enter in a 27, it's going to go into this else statement and run the rest of this program. All right. We also have something called alternative if statements. So if, else if, else. So we can check for different operations. So for this example, we output different responses based on the entered age. So this example, what we're doing is we're reading in the birth year, then we're calculating that person's age. Again, I wrote these slides in last year, so 2020 was the most recent year. So what I want to do is read in the age, right? Calculate the age. But before that, I want to check if the birth year is greater than 2020. So if birth year is greater than 2020, you cannot be 0 years old. Else, calculate the age, meaning that they entered in a number less than 2020. So if that's the case, I want to actually calculate the age. However, I can put in other logic in here as a result. So this example, I'm checking the birth year. If the birth year is good, you are not 0 years old, I calculate the person's age. Then based on their age, I have different responses. If they're less than 10, they're young blood. Else if, that means this is false. So they're older than 10, but they're younger than 50. You good. Else, meaning that they're older than 10, older than 50. We print out old head, right? Different logical expressions to change the operation of our program. So we run through this, we create our scanner object, we read in the person's name, we read in their birth year, set the age equal to 0. The person entered in 1990, okay? So we just use that birth year, 1990. So if birth year is greater than or equal to 2020, it's less than 2020. So we're going to go on. We're going to calculate the birth year, which is 2020 minus, for this example, 1990. So that person is 30 years old. We check this if statement. Check if age is less than or equal to 10. Their age is 30, so that's false. We go on to the next one. Else if age is less than 50. Their age is 30, so they're good. All right. So they entered in a birth year of all the way up here, all the way up here. They entered in 1990. All right. We create a variable to hold age. Then we check, is that birth year they entered in greater than or equal to 2020? If it is, we say you cannot be 0 years old. But since they entered in a 1990, that's false. We go to our else statement and we calculate their age. And we check if the age is less than 10, it's not, their age is 30. So we go on to our else if. Their age is 30 again, that's less than 50. So they're good. And that's it. Our program ends. All right. I know this sounds very complex, and following these logical expressions can be quite challenging, but they're very powerful as well. Because now there's something called a nested if. The reason we have a nested if is, say for example, we check to see if this birth year is greater than 2020. We say you cannot be 0 years old. So then it does this and it keeps going. It keeps calculating this. But we already know they're 0 years old. We don't need to keep doing this. So we can use a nested if, basically put an if statement inside an if statement. So what I'm doing is I take all of this, put it inside this else. That way, we know for a fact if the birth year is greater than or equal to 2020, they're 0 years old. Program ends. However, if that's false, we go into this else statement, then we do all these other checks. All right? So basically, if we know for a fact that they are 0 years old, we don't need to do these checks. They're pointless, right? However, if they are older than 0, we go down to this else statement, then we calculate their age, and we have different responses based on their age. All right? And hopefully at the beginning of the lab on Friday, I can actually run through this using the visualizer if we have the time. If we don't have the time, you know, the lab assignment is actually an if statement assignment or an if statement lab. So you actually use these in the lab and I can answer your questions as we go through the lab. And unfortunately, it just so happens that we had that wellness day on Monday. So I didn't have a lot of time to cover this stuff. But on Friday, hopefully I'll have a little bit of time to go through it and the lab will reinforce what we're talking about today. All right, any questions? All right, if there's no questions, that's it for today. I'll see you on Friday. Hopefully all of you can make it on Friday.